In this video, I want to introduce a very important formula to you. A formula that is widely used in industry and will be very useful in your work. With this formula, you can calculate the position of a control valve based on the input current. As you know, the controller sends a command signal to the valve positioner in the form of a 4 to 20 mA current signal. And it is the positioner that, using the compressed air available to it, and based on the input current it receives, positions the control valve in the correct position corresponding to that signal. In some maintenance situations, we may need to make sure that the control valve and the positioner are working properly. One of these methods is using this formula. In this formula, the valve position is expressed as a percentage, and the milliamp value, shown in red, is the input current of the positioner in milliamps. Now, let's go through this formula with an example. Imagine that the operation team suspects one of the control valves in the plant. They claim that the valve position is not correct. One of the methods we can use to check the condition of the loop, the positioner, and the control valve, is this. We use a milliamp clamp meter to measure the input current going to the positioner. Then we substitute the measured value into the formula. And using this formula, we calculate the correct valve position that the control valve should be in. In this case, the measured current is 13 milliamps. We substitute 13 milliamps into the formula. And the result shows that the control valve position should be at 56%. In other words, when the controller sends 13 milliamps to the control valve, the valve should be at 56% position. Otherwise, if there is a significant deviation, the control valve and positioner must be inspected.